What happens if you make parasitic worms interact with the juice of onions, garlic, and wild leek? We are constantly told that these plants destroy even the most resilient bacteria. Today we will test this in an experiment, and you will see for yourself if they are truly that powerful. We'll find out which of these plants can actually destroy nematodes, and which one will turn out to be ineffective. And you will see all of this right under the microscope. But before the test, let's clarify who our test subjects are. These are banana nematodes. Unlike their relatives, dangerous parasites that destroy the roots of cultivated plants in gardens or harm animals, banana nematodes are completely harmless. They are free-living microworms. In nature, they live in fermenting environments and feed on ordinary bacteria. However, their body structure and protective outer layer are exactly the same as those of parasitic species, making them perfect for our visual test. Now let's break down exactly which active substances are contained in our plants and how they differ from each other. At first glance, these plants are close relatives, but their chemical composition is different, and they affect living organisms in completely different ways. Garlic. Its main active component is allicin. What's important is that allicin doesn't exist in whole undamaged garlic. It only forms when we destroy the cells, for example by grating or crushing the garlic. At that moment, enzymes trigger a chemical reaction. For nematodes, allicin and its accompanying diallyl sulfides are extremely toxic. They can destroy the worm's protective outer layer and block its nervous system. Onion. Here, the main component is a lacrimator, scientifically known as thiopropanol S-oxide. This is a volatile compound released during cutting that makes us cry. Onion also contains a high concentration of quercetin, which is a powerful plant antioxidant. Onion is great at destroying bacteria, but whether its juice and volatile substances can handle the tough skin of a nematode is a big question that we are about to test. Wild leek, wild garlic. This is a wild relative of garlic. Allicin is also present in wild leek, but its main difference is its specific essential oils with a high content of vinyl sulfide. In the bulbs of wild garlic, the amount of active sulfur compounds is often even higher than in regular garden garlic. This is exactly why wild leek juice has a strong anti-parasitic effect. What is the key difference between them? Onion acts mainly through volatile compounds, while garlic and wild leek contain a high concentration of sulfides that work through direct contact of the juice with the worm's body. Now we will see which substance works faster and more effectively. Just a second ago, there was a peaceful scene on the slide, but as soon as a drop of fresh garlic juice touches the solution, pure chaos begins. The nematodes instantly sense the danger and start thrashing wildly in all directions. From their erratic, panicked movements, it's crystal clear. The worms are experiencing severe shock and are trying to swim away from the epicenter at all costs. However, they cannot escape. Just about 5 minutes pass, and the first signs of the end appear. Some of the worms lose coordination. They can no longer actively swim forward and begin to writhe convulsively in one spot. The rest are still looking for an exit, but their movements slow down noticeably, turning into heavy thrashes. After 15 minutes, the experiment can be wrapped up. More than 90% of the nematodes are completely paralyzed and lie motionless at the bottom of the drop. They are dead. Garlic worked so fast and ruthlessly because of an extremely high concentration of allicin. Contrary to the popular myth, this juice does not corrode the worm's tough skin like acid. Externally, the outer layer remains completely intact. The secret lies elsewhere. Garlic toxin is so volatile and oily that it slips right through the nematode's protective barrier, penetrating straight into its body. Once inside, it instantly strikes the nervous system and blocks muscle function. For these microorganisms, fresh garlic juice is a pure neurotoxin that shuts down their life functions in a matter of minutes. Now let's test the juice of wild leek. The first seconds of the experiment strongly resemble the garlic test. The nematodes panic in the exact same way, accelerate sharply, and try to escape the drop into a safe zone. They clearly dislike this new environment. However, the scenario changes drastically from there. The elimination process is heavily delayed. The worms continue to swim confidently, and for quite a while, it seems like the wild plant's juice isn't harming them at all. The first alarming changes begin only after 20 minutes, when certain individuals suddenly freeze in place, as if hitting an invisible wall. Another quarter of an hour later, about 60% of the population dies, while the rest are still stubbornly writhing. And only after about an hour, does the wild leek juice finally finish the job, completely immobilizing the last survivors. This slow action of the wild leek is explained by its chemical composition. It contains significantly less of the main garlic toxin, allicin, and other sulfur compounds penetrate the worm's protective skin slowly and reluctantly. This is where the accumulation principle kicks in. For a while, the resilient organism of the nematode successfully resists, and its internal systems manage to process and neutralize the incoming toxin. But over time, the poison penetrates inside drop by drop, accumulating to a critical level, and the worm's defense mechanisms finally give up. It is a 100% lethal but very slow-acting weapon. For this test, I managed to gather the largest, densest, and most active group of nematodes. As soon as the drop of onion juice covers this cluster, the worms begin to writhe frantically, creating the illusion of a violent reaction. But this burst of activity lasts only about 3 minutes. After that, the nematodes suddenly calm down and simply begin to crawl quickly and casually throughout the entire volume of the drop. We see absolutely no signs that they are feeling bad or uncomfortable. It's as if the worms have returned to their usual daily routine. 20 minutes pass, 0 casualties. After 40 minutes, only a few of the weakest individuals freeze in place, but this is an exception to the rule. Even after a whole hour, only about 10% of the population has died, while the rest feel perfectly fine. The conclusion is obvious. The juice of a regular onion has practically no impact on their health. Why did the onion, which makes humans cry, turn out to be helpless against the worms? It's all because the onion's main weapon is a volatile tear gas, thiopropanol S-oxide. This is exactly what caused the nematodes to panic in the first 3 minutes. However, this gas is extremely unstable in a liquid environment. Under the heat of the microscope lamp, it instantly evaporated and cleared off the glass surface. Everything left in the drop after that consists of beneficial antioxidants and vitamins. They are deadly to bacteria, but completely harmless to a multicellular worm. The nematode's dense cuticle easily held off the rest of the onion juice. The worms felt only a slight irritation at the very beginning, and as soon as the gas dissipated, they instantly and completely adapted to the environment. That brings our experiment to an end. Today we saw firsthand that fresh garlic was the most effective against the nematodes. Wild leek worked much slower, and regular onion didn't show any significant results at all. If you're interested in the world under the microscope and want to see more biological tests, make sure to subscribe to the channel and like this video. Also, leave a comment below letting me know which substance or product you want me to test in the next episode. Thanks for watching, and see you in the next video.